Hello everyone! Let us solve this given linear system here. We have 5x plus 6y plus 5 equals 0. And we have 15x minus 3y minus 13 equals 0. The solution of this given linear system should be a pair of x and y variables which could satisfy them. In terms of the name of these two equations, they are called to be linear equations in two variables because we can see they're x and y variables. At the same time, the exponents of x and y are just equal to 1. Their graph is aligned in the Cartesian plane, and the solution that we are going to solve later would be the point of intersection of the two graphs if there is. Now, we will not be graphing this one. We will not also be using the substitution method, but we're going to use here the elimination method, which means we are going to pick a variable, whether it's x or y, that we will be removing first to solve the other. And once that first variable is solved, we'll be using that to solve for the second variable. But notice that our equations, both of them are equal to 0. These two are in the form of general form because your right hand side are both equal to 0. In the process of elimination, you may not use this, but I'm just trying to implement this. We're going to come up with the standard forms of these two. So that's the first step that we're going to do here. So let me copy this equation, but now in standard form. So first equation would be 5x plus 6y. I will be making sure that there will be no more constants on the left hand side, so I'll be subtracting both sides by 5. And the other side would become 0 minus 5, so you have negative 5. Same thing will happen on our second equation. I have here 15x minus 3y. I'll be adding both sides by 13, so I have here positive 13. Now these two are now in standard forms, and I'll be deciding now which variable will be removed first. Now, in elimination method, you need to understand the coefficients of the same variable. If one of them or one pair is a multiple of the other, just like here, 5, 15. 15 is a multiple of 5. So it's easier for you to pick, to eliminate x by multiplying a certain constant to your 5x to remove 15x, right? But it's also the same with 6y and 3y because 6 is a multiple of 3. So which would you choose? Again, it's up to you. But since I see here already minus 3y, it's already negative, I will not be multiplying anymore a negative integer, but a positive. So it's easier, especially for some of us who are struggling with negative integers. I'll be multiplying the second equation by only with positive 2. So the 2 times negative 3y is negative 6y. Well, again, you can even remove x here. You can multiply, if you decide to remove x, you can multiply your first equation by negative 3. Okay, so that it would match with negative 15 and then 15x on the second equation. But take note that if you're going to multiply negative, it should also affect the other terms. So some of us might forget that there are problems with negative, so why not use positive multiple only? So again, the first equation, since I decided to remove y, I have here 5x plus 6y is equal to negative 5. And the second equation would become 30x. Okay, 2 times 15. The second one is minus 6y is equal to 26. Now with this, if they are added, we can remove y, and we can now solve for our x. We have 35x is equal to, this is 21. Dividing both sides by 35, x is 21 over 35. In simplest form, because they are both divisible by 7, you have 3/5. Because 21 is 7 times 3. 35 is 7 times 5. So your answer is 3/5. Noticeably, the result here is a fraction. Some of us also are struggling with fractions, but of course, fractions are acceptable because it's part of a real numbers. What you just need to do is to apply this on the both equations so that you could solve for the value of y. But here's the hint. Whenever you will substitute any of the two variables that you are solving first, use the original equations. Okay? Take note that from our general forms, we moved to standard forms, and one of the two was multiplied by 2. That's our second equation to solve for this x here. But there might be some errors in the process. So you could verify if there is by substituting the value of x on our original equation. Okay? Even if it would satisfy an equation that is a version of the original, you cannot guarantee that your answer is correct. So always use the original equation. So I'm going to use here the first original equation. You have here 5x plus 6y plus 5 equal to 0. X is 3/5. You have 5 times 3/5 plus 6y plus 5 equal to 0. Of course, you can do that. 3 plus 6y plus 5 equals 0. You have 6y plus 8 equals 0. 6y is negative 8. So y, when dividing both sides by 6, is negative 8/6, or in lowest terms, negative 4/3. Okay? It's also a fraction, and it's even negative. So again, just need to review your fractions with that. Now, this could already be okay, but as a process, let me use the same value of x to verify if we will get the same value of y, negative 4/3, when we use the second original equation. Now, this is just a verification. If you have time, I'm encouraging you to do this as practice so you would be really sure about your answer. So, the second original equation is 15x, that's 15x, right? Minus 3y minus 13 equal to 0. So, 15x, x is 3/5 minus 3y minus 13 equal to 0. That's 15 divided by 3 is not 3. Okay? Sorry, 15 divided by 5 is a 3. Okay? 3 times 3 is 9 minus 3y minus 13 is equal to 0. So negative 3y, you have negative 4 equal to 0. Negative 3y is equal to positive 4. Dividing both sides by negative 3, y is negative 4/3. Since both result to the same answer, you can now say that your solution is x being 3/5 and y being negative 4/3. If ever, just if ever, the first value of y is negative 4/3, the second will be not negative 4/3. You only have two situations. Number one, probably you have an error in substituting, or second, of course, there's no solution. Now, this already ends the process of solving this, but if you would like to join with me further, as I'm also going to show you another method of verification, the checking portion, you may. Checking here is, let's use both of the values for x and y in our original equations, and it should satisfy the equation. It would mean that the left-hand side would return to the value of the right-hand side, which is 0. Let's start with the first. 5x plus 6y plus 5 equal to 0. So substituting the values of x and y, you have 5 times 3/5, that's 3/5, plus 6 times negative 4/3 plus 5 must be equal to 0. Notice I am using question mark because this is checking. The goal is to make sure that both sides will be returned to 0, as the right hand side is already 0. This is 1, so 3. This is 2, right? Okay. Then positive 2 times negative 4, so minus 8 plus 5 question mark 0. Even if it's too obvious, simply continue until you reach this point here. We have verified that this solution really satisfied the first equation. Let's push further and should satisfy the second equation to really say that our solution is a solution. You have 15x minus 3y minus 13, 0. So 15 times 3/5 minus 3, negative 4/3 minus 13, question mark 0. Of course, we know that to be 3. So 3 times 3, 9. Here, we know it to be 1, right? But negative 1 times negative 4 is plus 4. Minus 13, question mark 0. And of course, 0 is equal to 0. We have now verified, using this process of verification, that our solution is really a solution. Again, take note, we started with the standard form, pick a variable to be eliminated, and verify your answer. This solution, 3/5 and negative 4/3, is the point on the Cartesian plane where the two lines intersect. Thank you very much for watching.